printing, you can hear 100% infill. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm cube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. What's up, everyone? How's everyone doing? I see a lot of people in the chat. Welcome everyone to the next Printbuster stream. You were surprised, right? That's not in the title because look at where we are. Helio Additive, and I'm with David. Welcome, David, to the live stream.
Hey, guys.
So, what is the live stream about today? What do you guys think? Hi, Zombie, Hobby Main, Builder's Mark. Beginning of the live stream, we welcome everyone. Cool. So which one is your favorite name? Didi Day. That's basically the challenge of every beginning of live stream. Pronouncing
the favorite name.
and pronouncing all the names. Freaking Newfie, how's everything? It's been a long time. Stay creeping.
Zombie Hedgehog.
Zombie Hedgehog is here.
So you know everybody?
I know, so let me see. Freaking Newfie, I know. Zombie, of course. Hobby Main, Builder's Mark, JTT, Moji 3D. Some of them are new. Stay Creeping, I think I haven't seen. Additive Atom, of course, I know. Yeah, most of them.
Yeah, that's cool. That's cool. Really nice to meet all of you.
What are we breaking tonight? Yeah, because so it's a Printbuster stream, so we're learning. And the best way to learn about something is to break it apart, right?
For sure.
What is Helio Additive? Great question to begin this live stream. So maybe the best person to answer this is David. Maybe you can introduce yourself first.
Yeah, I'm David. I'm the CEO and founder of Helio Additive. We founded Helio Additive 5 years ago. And the idea was that as printers are getting faster and materials are getting more powerful, we need to really understand what's going on in the printing process to solve problems like warping and cracking and effectively all the thermal related problems. And if we can give people kind of a map on how to get to a good print without actually forcing them to, really print, then we can make much more powerful things possible. Faster printing, more reliable printing, printing with less defects, printing with stronger layers. So that's effectively what we do at Helio. We have this physics-based simulation engine that's super fast, super easy to use, works with a ton of materials and quite a few printers. And when you press simulate, you get a map of exactly where your print is going to go. So you can start to analyze, where are there problems, where are there good spots, should you change build orientation, should you change your infill, should you change, all this kind of stuff. And that was kind of our first technology, very, very hard to do.
Yeah.
It's computationally, there's just a ton of stuff going on in the background, especially focused on the materials.
Yeah, because you started, so you released a product a few weeks ago that we are going to introduce today, but you've been working on this for many years, right?
Yeah, many years. Yeah, much longer than we expected. So we started way back in 2020 with our first polymer physics team and process team.
Yeah, you guys remember during COVID, we had all of this live stream, right? Where we were talking about how to improve 3D printing. And you remember the dream we had at that time where in the SLM industry, they had all these simulations already, right? But our industry didn't have because it was too complicated. Yeah. And we were thinking the first company that is going to develop a simulation will be able to have, that's like the core tool to then develop all of these simulation, optimization, simplification. Yeah. So I'm happy that today we are here in Helio Additive office from like 5 years ago, what we talked on stream. And the dream we had, we were thinking already, yeah, there must be a company that is able to solve this. And that company is Helio Additive. So I think you guys have a lot of questions. I'm hoping that we can answer all of them today. And by the way, big thank you to David. It's Saturday here, and he opened the office just for us to being able to do this live stream. So yeah, thanks again for taking the time.
Super happy to have you here and host you in our new office.
And do you guys remember the 3D printing mask? You remember I introduced like how I started in 3D printing.
Oh, you showed them that? Really? Oh, very cool.
So this is David.
Cool.
This is David. So thank you, David, for getting.
A long time ago.
Oh yeah. 2014.
14, yeah.
Yeah, that's how. And you remember I started. You brought a FlashForge Creator Pro.
Yes.
And then we had Blender, and we were trying. So the goal was to get something printed.
And Blender was really not easy at
that time. And then we
vertices. Do you remember that? Oh my goodness.
We were trying to just have like even just a cube. We were like, you know how Blender is, right? I love Blender, but the interface is overwhelming, right? So
it's changed a lot over the years. Right?
Yeah,
so
that's
that
true.
10 years ago.
That's true. And it was, I think we were printing with the filament that was with. Well, there was 2 spool on the FlashForge
originally
cardboard, right?
But then we quickly went to Polymaker PC,
and
right?
then because you already knew them from before.
Yes.
With Chopin, right?
Exactly.
Yeah. So
and PC anyway is my favorite plastic, so we had to do PC.
You see, because they know my favorite is Polymax PC, right? So you see, it's not rare to have someone liking PC. It's just a good material. Okay, let's see. Does anyone remember Mesh Mixer? Do you know Mesh Mixer?
The name rings a bell, yeah.
Yeah. So that was back in the day also. Thank you, David, for getting online for us. That wasn't the dream I had. I had a dream about a goat. Yeah, that's Little John.
Okay.
Okay, so the idea today is to present a product that has been released by Helio Additive 3 or 4 weeks ago.
Yeah.
And so maybe you can introduce the tool, maybe what the tool is and how people can use it. And by the way, there's a link in the description if you want to learn more.
Yeah, so let me just briefly cover it. We have this cloud-based physics engine, and if you can imagine that it's kind of a digital twin of everything that's going on thermally as something prints, as the material is deposited. And so we can predict really well how well the material is going to bond in different layers, how much stress is going to build up. All that is predicted for every material in the physics engine. So then, of course, we want people to use it, right? So then we have an API, and the API connects to Bamboo Studio. And then from within Bamboo Studio, you can actually call a simulation and then get all the data back to show you the map of kind of what's the thermal-mechanical, I guess, map of what's going on with your print. So if we'll see the interface later, right? Yes. But if you run a simulation and it takes about a second per layer to run, then you can get back this colored graph, and the colored graph shows what we call thermal quality index. So it's a combination of what's happening with the heat and cooling of the material. So literally the physics of the material. So red is too hot, blue is too cold. And you want to play around with your settings until simulation shows you, mostly green. It's a tolerant process. So that was simulation, and we launched that 4 weeks ago. But you can imagine if we can do that really fast. I mean, in the past, something like that would have taken, a week on a server. I remember when we started, we'd run this in the office on the server, and then 4 days later, the power would go out. And then you're like, oh my God, we've just lost the entire week's worth of data, right? And today this runs in seconds on AWS. So once you have that kind of thing, now all of a sudden you can do a lot of stuff with that, right? And one of the things we can do is start to adjust the print speed to try and get every element in the print into the perfect thermal window, right?
So maybe we need to break it down a little bit so to make sure. So what you're saying is, so the product itself is a tool that is used currently on Bamboo Studio?
Yeah, in Bamboo Studio.
So you put your STL and then they slice it And what they can do with this tool is to simulate what you call the thermal index of of different elements in the part.
Yeah.
And then, so what you're saying is that thermal index will allow you to define, can I say like the quality of the print or like the strength of the print?
The quality of the print.
The quality of the, so red meaning too hot, meaning like, for example, like a surface quality defect
or collapse, this kind of thing. Yeah.
And too cold, I'm assuming poor layer adhesion,
poor layer cracking,
right?
This kind of problems.
Warping also,
warping for sure.
Which is a very big discussion in our printbuster community, right?
Yes.
How to solve warping.
Well, I brought along the warping demo, right? I don't know whether you can see it, but you know, it's hard on smaller parts to actually see the warping. So you can see before that part is entirely curved, and then after optimization, we just get a really nice a flat part that's not going to curve away from the print bed.
Yeah, exactly.
Yeah.
And this is, do you remember when we had all the discussion, we were trying to figure out all the different settings that you're able to play with, right, in order to solve warping. And then what you needed to do is try a certain bed temperature with a certain printing speed, etc. And then you actually need to print it. And then if it warps, then you try to change, then you print it. And then basically that was the life of a printer, right? So because you cannot simulate. So the only way to do is trial and error.
Yeah, exactly.
So right now they are able to, so via this thermal index. So would you say this thermal index is what allow you, like, can you know everything about a print? Like you say, surface quality, stress, layer adhesion, warping index. Can you do more with it?
So I think, so the short answer is we can do a lot, we can't do everything, right? Like if your first layer adhesion is bad, we can help a little bit, but you know, if your print bed is dirty, there's not much we can do. If your filament isn't dry, there's not much we can do, right? Because you're going to have these, if you haven't maintained your printer. But within the printing process, everything that's thermally related, and most things are, right? We've talked about them, right? Surface defects, cracking, oozing, warping, delamination, I guess that's cracking, the strength between layers. So what we find is generally with, and so far we've just talked about simulation, right? We haven't talked about optimization, right? So maybe we should leave that
for
later.
Good part.
Which is the easy part, right? Where you just click one time.
Okay. So and you've been using polymaker material to develop this tool, right? Any reason you were using this material? Was it proximity or was it?
Look, we started during, I think there are a couple of reasons. One is, of course, we have very close partnership with Polymaker. The materials are consistent, right? So when we set something up, we know that, 4 months later, 6 months later, it's still going to work, right? The Polymaker engineers are very knowledgeable, and we've exchanged a lot of know-how with them. Right? So these are kind of reasons behind that partnership.
And I guess that consistent, is important because I'm assuming you did a lot of tests and you try to control all the factors that are changing. So having a filament that were consistent in their, let's say, properties would allow you to really pinpoint what affect what, right? So if you do 2 tests and let's say the filament, maybe the melt index of that filament is a little bit higher than this one, you obtain 2 different test results, then that will skew the result, right?
Exactly. You want to isolate as many elements as possible, right, to make progress. But nowadays, our model, I saw that there was a question about FEA. So we don't use big data, right, to do this, right? Our model is deterministic, it's physics-based. So in the physics engine, there are all the physics equations of thermodynamics and how the polymers will reptate and combine within the model. And then based on that, once you press simulate, it doesn't just predict things from a whole lot of numbers, it actually knows exactly what's going to happen according to the laws of physics. So it's deterministic, physics-based, not AI-based.
Okay, let's read the chat a little bit. So we have Aloha from Hawaii. Nice. Clayton from Hawaii. What time is it there? Should be around early morning. Is that correct? Does the API integrate with Orca Slicer or only Bamboo? I just got And IQX Explorer would love to try your product, but no Bamboo Studio. So yeah, any plan to integrate this in more slicers?
Yeah, so technically it's not a big deal. The engine works independently, right? So, and we have the API. It's pretty easy. We actually have an Orca slicer fork, but we're not in the main Orca slicer, right?
Okay.
So at the moment, our main kind of channel to users is through Bamboo Studio, but definitely the plan is to include it in as many slicers as possible in the future. I noticed, what was the printer that he mentioned? Can we scroll
IQX
down? Yeah.
Explainer.
Rando Tech Nerd, you've got an IQX Explorer. So at the moment, the printers that we've characterized for this, so we have to do a characterization for each printer model, because you can imagine, like, especially fans, right? Every printer has the fan in a little bit different place, right?
Yes.
So characterizing that thermal environment is a fair amount of work.
Oh.
So we do that for every model. So right now we have the X series and the H2D in our system, and that's what we're supporting. Soon we'll release the P series and the A series and the remaining H series printers. And then after that, it's the time to collect information from the community on, what would they like to see, right? Is it an Ultimaker machine? Is it a Creality machine, et cetera, et cetera.
Okay.
Yeah.
Little John is asking, does it need different models for different nozzle sizes due to different stresses?
No, so nozzle size information, because we're really focused on the deposition process. So as long as you're in a good extrusion window, we don't really need the nozzle size information.
Okay,
Yeah.
okay, great.
It's part of the G code, right?
Okay. And so what you were saying is right now, the limitation point is you have to characterize printer models.
Yeah, and materials.
And
And
of course,
materials,
and material.
Yeah, so right now we support that X series, so all the X series, H2D, and we have 25 materials that we support, and it's all on our wiki, so you can see as we're updating things.
Okay,
I think P series launches in like 2 weeks or something. Yeah.
And do you have PC at the moment in the list of material?
We have
What material do you have currently?
we have 25 bamboo and polymaker materials.
Bamboo and
I know
polymaker.
we have the bamboo PC, sorry, but we don't have the polymaker PC.
Okay.
But within the engine, we have the polymaker PC.
You're able to
in Bamboo Studio.
You already characterize polycarbonate, right?
Yeah,
So
absolutely, yeah.
the reason I'm asking about
TPU,
PC is
PC, ASA, ABS. All.
yes, because that's the
PLA.
one. That's the one we're struggling with, right? I mean, it's our loving filaments, but maybe because we struggle a lot and we finally, understand how to print with it. So maybe that's how we created bonds with PC, right?
And when you get a beautiful PC print, it's amazing, right?
Yes.
So these are PC optimized parts. Just printing. Let me see, is this optimized? Yeah, on the H2D, printing just perfectly. Absolutely great material.
Yes, I agree. And I think the Sendinaden Max was Polymax PC, right?
Yeah.
And we had
TPU,
one
and we had a
TPU.
TPU combination. Yeah. I think
we were already doing
multi-material.
Multi-material. Oh yeah.
And then that's why I like it, because TPU is my second favorite material, right? We've also got TPU. We've got a TPU in the list, and TPU and PC actually bonds really well, right? So it's one of those combinations.
Yeah, it was so we were scanning and we were doing like the edge in TPU, and then the mask was in PC.
If you think what we were doing back then was fairly sophisticated for the time, right? We were probably
absolutely
ahead of the curve of what people were doing.
I remember on stream we were talking about because I kind of started during COVID, and then we were like, can you imagine we started this in 2020?
Yeah,
that would be like awesome. So
I see there was the Prints and Planks comment there, right at the bottom about the results. So for context, real world results haven't been positive. Understand people are more likely. Yeah, look, there's so much complexity in different parts, different materials, right? That it's very difficult to make a claim like, oh, you're going to be 50% stronger across the board. What we can say is, in most cases, you will get a speed improvement with optimization. And in most cases, you will get a interlayer bonding, so strength improvement. but we can't promise that with all parts. Yeah. If you look at our wiki, there's a plus, of course, it changes per material, right? Some materials we have less impact, some materials we have more impact. So you can check out on our wiki for each filament, we've kind of characterized what we think will be the impact based on speed, strength, and warping. So you can see some filaments you just get speed and you don't get much impact on warping and strength. Some filaments you get huge strength improvement, but the speeds stay pretty much the same versus a normal preset. Yeah, this is just the nature of the game we're playing, right? In 3D printing, that there's just so much variability.
Okay, sorry, I'm preparing the demo in the background at the same time. And yes, Builders Mark, we are going to show the demo. I'm opening my Bamboo Studio so I can show you.
So demo is always a dangerous thing, right? The demo effect.
Live demo.
Well,
it's a live product, so you guys can also. By the way, I saw about AWS being super expensive. I believe the simulation is free.
Yeah. So simulation is free, and then we charge for optimization.
So I'm going to load.
Although if you DM me on Discord, I can also add some free optimizations to whoever wants.
Ooh.
Free, yeah. It's no issue. So people DM me, and then I just add 2 or 3 in our backend. You just have to first click through to our storefront, because we need your email address, because otherwise I have no idea who I'm going to add a free optimization to. But you don't need to buy anything, just add it, just DM me and I'll add a few. Yeah.
Oh, how about we create a Helio Additive channel on our Discord, and then we get people there.
Do you think that would work?
Yeah, I think so.
Like that?
I think so.
Yeah, that would be cool.
Let me create. Let me do this. Okay, so on our Discord and partners, I will create a new channel.
Cool.
That will be Helio Additive. So let me put Helio Additive. Helio Additive. Just making sure.
Right.
Okay, the channel is created. So you can go on our Discord, discord.formica.com, and then you go on that Helio Additive channel under the partner category, and just say hi there. And then what we're gonna do is, if you have your DM activated, then just say hi there, and then David is going to reach out. And if you don't have DM activated, then David will post a message there so you can DM him. That sounds good? Okay, so let me show you guys the simulation. So let me share.
Yeah, so can I just say, people often ask, like, to clarify, what is the difference between simulation and optimization? So we're going to see both now. So for me, kind of the analogy is, you've got this amazing sports car, you're driving it through the forest at night without headlights, without a dashboard, and you're just going to drive that sports car, I hope, really, really slowly, because you don't want to run into a tree, right? So what we give you is, we give you the headlights, the dashboard, the GPS, so that you can drive your printer as fast and as powerfully as possible, right? So simulation is kind of like the map in that analogy. So we tell you, we give you a map of the whole environment and tell you how you can get to places, but you still have to get there on your own. And then optimization is more like the autopilot. So it's really pretty much one click, and then it'll take you to the destination. So that's the analogy if you're trying to see the difference.
So right now we are creating the map, right? We're basically creating the, so you're talking about the thermal index map of the model. So maybe you can explain a little bit what we're seeing here?
So you did this with the X1 Carbon and PLA Basic.
Yes.
And you can see the different colors. So everything blue is on the colder end. Everything red is on the hot end. But we're not showing temperature here. We're showing something called the thermal quality index. And it's kind of a combination of what's happening temperature-wise to each little voxel element in the part, combined with the physics of the material. right? So combined with, how well is it going to bond together? How well is stress gonna relax? That kind of thing. So you can see here, the red is at the top, so we're going to ignore that. But you can see the bottom is a little bit cold, and then you can see it's getting more and more green, so better and better as layer sizes get smaller and as it goes up. So if we were to now wanting to debug that, if you go to our wiki, so we put a lot of effort into know-how on the wiki, wiki.helioadditive.com.
wiki.helioadditive.com.
Because we know that to debug things with simulation and so on, you still need to put in effort. So if you go to,
let me share at the same time.
Yeah,
making sure they can see.
Yeah, so if you go to on the left, there.
Yeah, you can.
Yeah, I can drive it.
You're more familiar.
Yeah, I can find it. So there's a print debugging flowchart that we designed specifically.
Oh, we like flowchart.
Yeah, so effectively, if you get a simulation result and you're like, oh my God, what do I do now? Then the print debugging flowchart is there for you to then go through and kind of see what should I do. So you see, okay, it tells you dry your material, etc. Now you've simulated, and now you've got blue. So blue means too cold. Okay, let's go here. Sorry, here, too cold. So now the first thing we want to do there is reduce fan speed. And then we go through and every time we can run a simulation until we get the result that we want. You don't have to have, if you go back to Bamboo Studio, right?
Where's my Bamboo Studio? Yeah.
Yeah, you don't have to have everything completely green.
Yeah.
Right? It's not, we know that FFF is not like that black and white, right? But you want to get as much green as possible in your part. So remove the hot spots and increase the thing.
Okay. So maybe let's go a little bit in.
Go back one more second, because I think this is cool. We're not doing this for the outer layer, right? So we're doing this for every inside part, right?
Yeah.
So every single voxel in that print has now been simulated in a second per layer.
Oh, okay. So anything on the blue side is too cold. Anything. So maybe let's do a little bit of a game. If you would be, so you can do that also on your computer, right? Just maybe let me put the list in our new Discord. Let me put so I think you have a Kickstart page somewhere here, right? What is the link again? Kickstart. There you go.
Yeah.
So I will put that on our wiki. Oh, nice. I see some. Not on our wiki, on our Discord. Sorry. So I just posted a link on our Discord. And then, so the question is the following: what would you do to make? So looks like we're pretty green here. Here we're pretty blue. So what would you do in order to make these parts more green? Okay. Don't cheat. Don't go on the Helio Additive wiki. What would you do to make this better temperature? So it has to be green. And I need to blow my nose.
Can I address one of these comments?
Yeah. You can click on them if you want.
So Prince and Planks, you wrote about the benchy hull line. That is a really interesting topic.
Oh yeah.
Really interesting topic. So results vary per material, but definitely the benchy hull line is an issue here. And we can definitely have improvement when you have, the benchy hull line is an issue where layer size is changing dramatically, right? So this is a really interesting topic that we talk about as well. Slow down or reduce fan speed, yeah.
So what do you think of some of the?
I think the reduced fan speed is good. It's a fairly big part, right? The scientist. It's a reasonable size part.
What does the gray on the base mean? Maybe not simulated?
No, it's just those top layers, we just leave them neutral because effectively we want to predict what's happening between the layers.
Oh, yeah. Okay.
So it's kind of irrelevant in that case.
With an inductive heating hot end, you might be able to adjust temperature per layer in the future. Do you think that could be a good idea?
Look, I'm a big fan of inductive heating hot ends. I've seen a couple of them at fairs in Europe and so on. But I think in this particular, so effectively your hot end, you want to get within the right extrusion window, right? But what happens after the material leaves the hot end is it cools down so fast that the nozzle temperature change itself is kind of irrelevant in the big context of the print, right?
That's what you were explaining yesterday, right?
Last night,
so if you extrude at, let's say 240, the time it takes to reach the layer basically below, then you would be at a certain temperature. But extruding it at 260, it would basically cool down even faster because it started at a higher temperature, and the end temperature would relatively be the same.
It's relatively the same, right? So changing nozzle temperature doesn't really control thermally what's going on in the print. Your chamber temperature has a huge effect, right? Your print bed temperature has some effect. The speed of your printing actually has the most effect. And then, of course, the nice thing is with simulation, we can't change it in optimization because we only control the speed at the moment. But you can change your build orientation, your infill, the number of shells, right? All these things have a big impact here.
And are you familiar with the Print Buster community?
No, not really.
So what we're trying to do is, because I'm going to say something after, but I want to put the context, right?
Okay.
So the Print Buster community is about also understanding 3D printing as a whole, right? From the printer and the material. And what we're doing is a lot of tests. So what I want to say is all what you're saying here in Print Busters will be put to the test.
That's cool.
Yeah, so that's why, when I told you,
made me nervous.
when I told you that the best way to have feedback about your product was the Print Buster community, that's what I meant, because we're not doing this to prove anything, right?
Yeah.
We have the same objective of understanding 3D printing. So I think all of these, you guys know that I received all the toys, right, in the new office. So I think we're gonna have a lot of fun with Helio Additive, where we're gonna try to optimize different models, and hopefully our Print Buster community can maybe help and have some synergy with the Helio Additive team, right? That's what we wanted to do. We really wanted to, one of our dreams in this community is to release some papers where we learn something and then we share with everyone. But working with company is also something that we would like to do.
Yeah, so my vision for 3D printing started with what we did with Send It Out, right? So I really want to see a printer in every home, maybe, but more than that, the kind of series production with FFF or small scale series production to decentralize manufacturing. And this was kind of the biggest bottleneck. We're in beta, we need tons of feedback, and we're very open to it. You will see our team engaging a lot on our Discord. We're in different time zones, so it's hard to answer all very, very quickly. But we engage with everybody and try and answer the technical questions they have.
And so how do they access your Discord? Is there a link on your wiki?
There's a link on our website. Okay. There's a link on our wiki. Yeah, I'll post a link to it from. Can I do that? Post a link to another
you can take your invite link and then you can put it in our channel.
I'll do that.
Great. So let's go through the chat. There's a couple of questions. So how well this work for higher temperature and field filament like PPSCF or PCGF?
So effectively, the higher the temperature material, the higher TG material, the more value we can add, right? Like we saw that with PC. It's a quite high temperature material. It's difficult to work with, so we can add a lot of value. For filled filaments like glass fiber or carbon fiber filled filament, you tend to see less warping anyway, right? That's the role of the fiber in making it easier to print. But we can definitely add strength and speed improvements. If you go to our wiki, there's a filament section. Maybe we can share that briefly.
Yes. There's a filament guide.
Yeah. And what we've done is, because of exactly questions like this, Helix 4D, we've tried to do a standard test for each filament that we support. So if you go down, go down, go down, we just list methodology, methodology, methodology.
Is that the CNC Kitchen?
Yeah.
Nice.
We used it because it was kind of an industry standard.
Yeah,
It was
nice,
kind
nice.
of a community standard. We also do more normal dog bone tensile strength testing.
I recognize these materials.
You recognize them good. I would be worried if not. But you can see that for each of them, we kind of list what our result was. So I think the first one is the first column is speed. Go up to the top again, and we can see what the headers are. So print time improvement. The second one is warping improvement. Third one is strength improvement. So we listed the methodology. We listed what we do, and you can replicate this yourself. Yeah. So we've tried to everything that we claim, we've tried to back it up with data.
Looks like it worked really well with 6-2L.
Yeah, but you see, for instance, warping is a big reduction and speed is a big improvement, but strength there wasn't a lot of strength improvement versus I think low means like 10% strength improvement.
Okay.
Right?
And for ABS, it's pretty good also.
Yeah, for the ABS, it's excellent. Yeah, and you guys have a great ABS.
Thank you.
Yeah.
Nice.
So we're going to be adding more and more materials, and there's actually another page where it just says, what materials and printers we support, and you can just comment down there and say, oh, I want this material supported, and we'll do our best.
Yeah, I think we will dissect this wiki. A lot of information.
Yeah.
Oh, I think that's the chart that explain a little bit the core technology, right? How you're trying to improve every part of the print.
So we've been fairly transparent on the wiki on how we do it, what we do. We didn't want to be like this mystery black box, especially not. There's a ton of 3D printing users that aren't super sophisticated and don't really care, right? They just want to press print and get a good print. And then there is the community, like I think print busters, right? Yeah. Where you really care and you want to understand, right? Yes, and we want to. How can anybody trust us if we're not transparent with this kind of stuff, right?
Yeah, that's true. And also, I think we're still in an industry, at the very beginning of the industry, where I believe a lot of innovation, a lot of creative idea is still a very big synergy between the market and companies.
Yeah.
So more mature markets, I think maybe the people are less into growing that industry, rather than in our industry where there's still so much synergy between the market and the companies.
We see that a lot, right? Working with our business customers, those guys go home and then they 3D print.
Yeah.
They'll have some machine which they're working on in the office, and then they'll have others at home.
Question from LX40 Solution. Thank you. I have an interest in how the iron high-low, what is this one, does on-the-fly thermal analysis, and how hot spot geometries in the part affect the critical area of any given part. But thank you. What is the iron high-low? Okay, time to Google this. Let me check. Iron high-low. What is this?
That doesn't look like.
Not much. Is there a typo? Is this something we can collaborate with you and link our Team 7 Discord? Yeah, maybe you can send more info on our Discord, because I don't have much results for this. I'm not even sure. Is that a printer? Is that a software? Is that a project? Will the software suggest setting to improve the print or just temperature analysis? Ooh, that's a great question.
Diablo Spawn 2.
So let me share again, and David is going to explain to you so we have the map now,
which is simulation.
Which is the simulation. Now, David already explained how to improve it, but there is a better way.
There's a better way, because I think, like you say, Diablo Spawn, what we really want is we want to be able to, just click and get a better result, right? So we have something which we call optimization. And I don't know can you open optimization there? Can you open so if you click on the Helio logo, right, you have two options. One is simulation, which is totally for free. We don't charge for it. And then the second one is optimization. And in optimization, what we do is the physics engine runs many, many times to adjust the print speed in such a way that we try and get as many elements in the part to green, to a good thermal window as possible. It's not always possible, right? Because you start running up against material and printer limits. Because sometimes you just hit max speeds on printers, or sometimes you hit max speeds on or max thermal conditions on the material or stuff like that. But what the optimizer will do is try within the limits of the material and the printer and the part to get everything as green as possible. And it does that by adjusting the print speed, because as you adjust print speed, you massively impact temperature.
Okay, so optimization.
Are you going to share your screen again?
Yes.
Yeah.
I just got
cool.
my add-ons first.
Cool.
Okay.
So you can see, you have a couple of options here, but you don't even need to change this. You just like you could do optimize outer wall. Yes, it's fine. That's if you want, like if you're confident of your surface quality and you really don't want to mess with your surface quality, then set it to no. But if you want kind of the maximum speed boost and the maximum strength boost, then you want to set optimize outer walls to yes. And the
maybe I think you need to go and give me some.
Are you on the latest version of Bamboo Studio?
I think so. Let me restart maybe, because there was 13 here.
Yeah, there were just now. Anyway, then once you click, optimize, if you have optimizations available, which Nicola right now didn't, then.
Sorry, guys.
No,
I'm cheap.
My fault. Then it will run. It takes a bit longer than simulation. Obviously, it's running simulation many times, right? But it just tries to get everything in that perfect thermal window, and then gives you a new G code that you can print with. And like we discussed before, you can't get a perfect result every time. But what we try and do is get as good a result as we can get, given the limitations of the material and the printer. So second time out, there you go.
Yeah.
So.
Maybe.
Okay, let me sort it out separately. Obviously,
okay. Maybe I can show them the store at the same time. That's a good opportunity. Let me show you guys the store. There we go. So I think I can connect to mine already, right?
Yeah. But you just get your one-time password.
Let me get my OTP. By the way, any of you used Helio Additive before this live stream? I'm waiting for my OTP. Is there, maybe let's cover this one. Is there any worries that Bamboo Labs may decide to not allow you to integrate with Bamboo Studio? I think you had great experience with Bamboo, right?
Yeah, the collaboration has been a really good experience. They're working together with their software team has been a lot of fun. They're really just very professional and very, very action focused. For us, what we want to do is be as integrated as possible with every slicer, right? We start with Bamboo Studio, but we also would love to be integrated into Orca Slicer, into Cura, into even like something like AstroPrint, right? Our engine is in the cloud. It doesn't really matter to us which slicers we support. We just want to support as many of them as possible. Mm-hmm. But it's early days for us, right? We're still so young. We have to do these things step by step.
I'm the co-founder of Team 7 Beta Testers. This system looks very interesting. What slicer does it work with? I believe Bamboo at the moment.
Bamboo at the moment.
And trying to expand to more, I'm guessing Orca Slicer next?
We'd love to, yeah. So it's also a question of reaching out to the Orca Slicer community, right? And working with that team and building trust. Yeah.
Okay, next, it was mentioned that the optimization can improve different areas of a print, speed, strength, etc. It doesn't look like the user can choose what areas they want to focus on. Have you considered from a UX perspective to provide a UI for that? Example, user can choose to prioritize on strength or use sliders as control.
Oh, yeah, that's what we were discussing yesterday evening in a way, right? Yeah, I think it's a great idea, prints and planks. Again, it's early days for us, right? So we're taking feedback from the community. We're working out what are the priorities. Right now, you can't choose except for the outer layer, right? Choosing not to do the outer layers or to optimize the outer layers. I think sliders sounds good. Interestingly enough, how do I describe this? Usually when you're going for speed, you're also getting strength. I mean, the optimizer will slow down, like if you've got a very narrow spiral, it'll slow down to try and reduce the heat of that part, if your layer size is very small. But generally, the overall object will be sped up. And so you don't really trade off in most cases. When you get speed, you're also getting strength. Does that make sense?
Before our discussion yesterday, no, but after our discussion yesterday, I think I start to understand. Yeah.
So I think still prints and planks idea is really good and very useful. But at the moment when you press optimize, you're not trading anything off, so to speak, right?
Maybe that's a question for you guys. Let's say we have a tool now that is able to simplify your slicing experience, right? What would you like the tool to do? I'll give you an example. Yesterday I had a talk with David, and what I told him is I needed to print like a pretty large part, but I needed it to be finished before I leave, before I come to this business trip. So I tried a bunch of settings in order to make this fastest print, but that would still look good, right? So I tried the minimum amount of infill, minimum amount of outer shell and inner shell in general, printing speed. But it was like, this type of thing where you do some trial and error in the setting, and then you slice it, and then you check the print time, and then you go back, you try to change, and then you slice, and then you check the print time. So the idea I shared with David is, what if Helio Additive, with the core technology they have now, you could just click and say, I want the fastest print that would still look like a print. It doesn't have to be super strong or anything. I just want it ready before I go, basically. So that's one idea. But what would you guys think? What would you like out of that type of tool? Like, I want the strongest print that is possible, basically, with that material on that printer, and you don't care about the printing time, for example. Like, what would you think? So maybe at the same time, while you guys are thinking about what Helio Additive could do for you, what would it be useful for you? Maybe we can introduce the different plan. So all the simulation is free.
Yeah.
And but if you want the autopilot, meaning instead of you trying to, so you have a map, so you can change some setting and see if you're going the right direction. But if you want it to do automatically, then there is some plan. Maybe you can explain.
Yeah. So we divide our plans between personal and business. We're very privacy focused. So we really try to make sure that we only get the G code, right? We don't get STLs or anything like that. We treat the data really carefully. But the main difference between personal and business is business, if you're printing commercially with sensitive parts, you obviously want some kind of legal guarantee that's stronger, right? Because your livelihood is on the line. So that's the difference between personal and business. In personal, we start at like $14.99 per month, which gets you 35 optimizations, or you can just buy an add-on. So add-ons will actually work without the subscription. And that was feedback from the community. They said, for project work, we just want to be able to buy an add-on. So we just allow people to buy an add-on, get 10 optimizations, and those won't expire. And then we have an annual plan, which is a 30% discount over the monthly plan. So that's how we handle the kind of personal users. I guess most of the Printbuster users are personal users.
Yes, correct.
So that would be kind of how we approach you guys. And then business is for people who are running large print farms, people who are doing in a factory manufacturing, and there we charge more for the privacy, for additional support. There's then email support and kind of troubleshooting together with the customer. Yeah.
So maybe one point to clarify, because I see 35 optimization is very low considering that I have 3 printers going 24/7, 365. So I think you can optimize. So it's per model optimization, not per print, right?
Yeah, per model. So
Okay.
I assume if you're Diablo Spawn 2, you're printing different things, but you're not printing every time something different, right?
Okay, so 35 would mean 35 different models.
Yeah, exactly.
Not 35 different print. Okay, so like for a print farm, for example, let's say, there's, a very big growth in China for print farm, right? So let's say they print a dragon, they print thousands and thousands of dragons. So it would be one optimization for these thousands of dragons, basically.
Exactly.
Exactly. Got it.
Yeah, even if they change, if they're not changing the material, right? But even they change the color, but they keep it the same material, it's pretty much the same.
Mm-hmm.
Yeah. Prints and Planks had another cool question about API. So actually, that's how
you guys are building a bond between David and Prints and Planks.
Yeah, keep the great questions coming. So we actually do have an API, right? The engine, the physics engine, the cloud has an API, and then it's really easy for developers to then hook onto that API and build this functionality into the slicer. Most of the slicing area is open source, right? So you can see exactly, we have a Orca slicer fork where you can see exactly how it was implemented. So it's quite easy for developers to then say, okay, this is how it was done in this slicer. Now, how do I do it in our slicer? Right? The other thing here, and I think that's also cool, we have customers now who just want to run Dragon. Dragon is the name of our technology, headless. So they run it without a slicer. So they want to run it without a slicer. We don't have an implementation yet, but where effectively every time something gets printed, it just automatically goes through Dragon. And then they don't even look at it. They just send it to the printer. Which is really cool, right? It's a very different way of kind of thinking about.
When you think about it, you're basically asking people, do you want the print to be better? You don't need a UI for that, right?
No.
It's always yes, basically. The answer is always yes. Okay, let's go to the next one. Need a slicer to allow me to control the scaling of infill in just certain areas of the print so I can control the thermal properties of the print better. Does Helio Additive work on this way?
So the answer is no, we don't do tool pathing, and infill is part of tool pathing, right? But I think it's a really interesting point, Helix 4D, because your infill density does have a huge impact. What you can do with our technology is you could, let's say, break your part into different parts, right? And then we would, if the slicer can support it, we can simulate it. It's not an issue, right? It's not an issue for us to simulate.
Oh, that's a good idea, Rando. Have you considered optimizing for transparent filament? So basically, there is some Reddit posts, some Facebook posts. I'm standing because I need blood flow. And they're basically trying a bunch of settings in order to print the most transparent possible. And I think that there might be some relationship with thermal index, right?
Yeah.
So.
Yeah, absolutely. But we haven't, this is a really interesting point. I don't know enough about it to give an answer, but I think it's really interesting, Rando Tech Nerd.
I think once, that's the exciting part. Like you have like a core tool.
Yes.
And then you can model it in anything you want, basically. So.
And I think a lot of those things are, over the horizon, right? So right now, what I'm excited is in 2-3 years, what will people be doing with our technology? Right? And I'm sure I can't imagine today what people will be doing in 2-3 years. And that's the exciting part.
Yes. Let me go back a little bit. I think Nico touches on a good point. Being able to generate optimal print profile based on use case. It's kind of what I'm doing with the default profile that come with slicer.
Yeah.
Yeah, I think so. Let me think about it. So maybe a question for you, David. How much, because profile preset at the moment, they are material printer dependent,
Yes.
right? But they are not geometry dependent. So how much do you think geometry plays a role in a good preset?
I can't quantify it for you, but at least in our testing, a lot.
A lot. Okay.
Especially when you have a huge amount of variability in layer sizes, right? It gets.
My intuition would answer the
Yeah.
same. Yeah. So you can imagine how important this type of tool is, right? We're not going to have one profile per material, per printer, per hot end, extruder system, and per geometry, right? At some point, we need something more automatic, right?
And I think it's like that with a lot of also the standard side, right? It's like I remember when I was in polymers, you have a UL yellow card, I want to say, for flame retardants, right?
Yeah.
And if you are just selling a material, it's very easy to do in injection molding because you send it to a lab and they'll do a test and they'll give you back the results. In 3D printing, UL doesn't really have a standard. They have some things, but it's geometry specific. It's not any geometry. They say, yes, it's this UL certification, but it's only for this part. Because geometry is such a big factor here, right?
Yeah. You could have the same material, the same printer, and one model is super strong and the other is super brittle.
Exactly, because your process settings were a little bit different.
Yes.
And the geometry is different.
I'm a software engineer focused on web front end by trade, so UX is important to me. Got it. Yeah. And I think, like right now, in some way, from a product perspective, you're just getting started in a way that you spent the last few years building the core technology.
Yeah.
And now you're starting, you release the first version of the product, and now you are now into the product design, etc., right?
And that's, I think, the Prince and Planks, like that's all that area. We're 21 people at Helio. Most of those are process engineers, polymer physicists, numerical simulation experts, right?
How many marketing people?
You're looking at
marketing team is here.
We have one very, very overworked customer success engineer, and marketing is me, right? So we've built, like you said, we built this very strong technical foundation. But when it comes to then the user experience or talking to you, we're definitely in beta. We're still very, very much in beta.
And that's why they need you guys. They are at the point where they need feedback. They need to understand what you need. Rando is saying, no, I think we got this one. Hey, good to see you, Ramoline. Another, what is this? On that note about printing transparent filament, it would be awesome to address seams, improve scarf seams. Is there a possibility to do that with Helio? Like when it changed layers and then there's like that small gap block kind of thing?
I don't know enough about it right now. I know that in the future, there's a lot of work on bridging and overhangs and support removal that we believe are possible and that we have worked on in the lab, but are not in the product yet. But I haven't seen anything on scarf seams from the team.
I forgot we were still on that screen. Okay, great. One thing that I wanna maybe brainstorm a little bit is when you started Helio Additive, I'm pretty sure you had a vision, right? Like a 10-year vision, a 15 years vision. Can you introduce a little bit more about that vision? Because I'm guessing it's very exciting to have that first step that you just took, around today, right? So what is the end goal for Helio Additive?
Look, I think in short, the end goal is for us to be ubiquitous. So I want to make sure that every object that is printed is going through a quality check with us, right? That we've done the quality check and that that this is as good as you can do within your hardware, material, and the part limitations, right? And that we are kind of a seal of quality that you say, okay, yeah, this passed through Helio's optimizer, tick, we can go ahead with that, right? And to do that in every slicer with every material, that's the end goal. But for me personally, I feel, we were at a stage for a long time where kind of printer innovation was stalled, right? Can you imagine that FlashForge Pro that we had in 2014 was still for sale in 2020?
Yes.
Right? Which is pretty scary to think about it, right? So what I really want is to drive more innovation in the printer space. The stuff that excites me is really fast printing, right? I really feel we're nowhere near what should be fast printing. And the faster the printing, the more value we can add, or the more problems we can solve. Multi-materials, right now we don't support multi-materials, but you see with all the tool changer stuff that's happening, right? For me, dual nozzle has never been like on the FlashForge Pro or IDEX, it's never quite been multi-material for me. But with the tool changers or hot end swappers or whatever, this becomes possible, right? And so all of a sudden you're creating this way bigger space of possibility for 3D printing, but you're limited by software. If the software doesn't allow you to do it, then what's the point, right? So this is the space that we want to fill, is make you squeeze the last bit of performance out of your hardware material part combination.
And I guess it was always that type of race where you have printer improvement, material improvement, slicer, software / firmware improvement, and it's basically a race, right? And so maybe that's the question. Where do you think we stand as of today? Is the printer in advance, material in between, and the software here, or how would you?
It's very subjective, right? So
of course,
just my opinion.
Of course.
I think printer is still a big limitations. I think what we see with Helio a lot of the time is we're just reaching the limits of what the printer can do. And so if your printer was able to print faster, we would be able to squeeze more performance out of the material in the part, right? So I think there's a long, long way to go there. I think on the software side, look, slicers are all still manual, right? You're still depending on the process engineer to tune the preset to give you a good result. And
hope that the profile is available.
But it's 2025. It shouldn't be like that, right? And okay, we're here now, but it would be nice to see way more innovation on the slicer side. My feeling is materials are doing pretty okay. I think there's room for more variety. Like I think we could do with another 1,000 material types in 3D printing. But I think, high-speed filaments and so on are already pretty amazing.
And I think it's also from a business perspective, right? There is also that limitation where, let's say you are not the limitation. Then, so let me give a concrete example to explain my idea. Like a high-speed filament, right? Let's say we're able to make a very high-speed filament, right? Way above what printer can do. But from a business decision perspective, then you have to take the decision. Either you release it, but nobody can really use it.
Absolutely.
And then it's limiting innovation, because you're like, but then there's no point. There's no market for it. And finally you don't do it. Then finally nothing moves. And then we're all stuck, right? So I'm wondering whether...
And that's what we had a few years ago, right? I feel.
Yes, exactly. And maybe we are... And that's, so for example, Helio Additive, that's a little bit, we need companies that are just breaking through, right? They're just, we just break through, because then it will unlock the others. So printers is going to say, now we are able to do that. Then let's go and, develop more hardware, improve the hardware, and then material similar.
But it's expensive, right?
Of course.
Helio has been 5 years of my life, so half a decade until now. We have a team of 20 people, and after 5 years, we're just launching a product. Right? You imagine the stress in terms of trying to find money for that, in terms of in the first years, we were so purely research that you make so many wrong paths, right? And then investors ask you, well, but you don't know, because you're doing... you're doing fundamental development work, right?
Yes.
And I feel we're really committed to the industry, and I think we've proven that by sticking it out 5 years. But very, very hard.
I can imagine. I can imagine. Okay, let's go back to the chat a little bit. Are you going to allow beta tester to have free access to the optimization? Well, actually on stream, David offered that if you reach out to him via our Discord or their Discord, he will allow you to have some optimization.
Yeah, absolutely. DM me with your email address and having created an account, and I'll add some free optimizations, 2 or 3 or 4 free optimizations to your account.
Awesome, awesome. And next is 3D printer. Just watched some of the getting started videos. Looks very impressive. Oh, you have some tutorial?
The wiki has a lot of stuff, right?
Oh, okay, okay. Great, nice. For a business printing parts for other businesses, it would be awesome option to improve part quality and improve performance.
Yeah,
absolutely.
Yeah. And for us, enterprise customers are super interesting, right? People printing millions of things. There's not so many of them today, but we've had conversations with most of them, and I've started working with some of them.
Yeah, I mean, I still remember how, like for example, when we were doing the mask, how many iterations it took to finally be able to print it properly, because you remember we have all of these patterns inside. There was like some big overhang.
And do you remember then we had cracking with PC?
Yeah,
and
exactly.
then we called Xiaofan, and Xiaofan said, I kneel it.
I
said, okay, fine.
Yeah, so I think that's the big change. So would you say the mission of Helio Additive would be like to simplify the printing process, or?
It's certainly simplified to the point of having like one click and just go, right?
Basically.
I mean, that's the dream. And I think the optimization is kind of the first step along that path.
Because we don't really have, when we think about like slicer, we're used to slicer, but maybe when 3D printing will really be mainstream, maybe slicer will not be there.
Yeah.
Right. Maybe it will be, you found a model, you send it to your printer. It's like
well, in other manufacturing technologies, that's all integrated.
Exactly.
The CAD experience, right?
And I think it was, I don't remember, was it Race 3D that had an embedded slicer? Do you guys remember there was a printer? I don't remember, but their firmware, like there was some type of online slicing, or it was the Mod 3D, or like this very early Kickstarter that really tried to build that smart experience. But yeah, because like I'm thinking 2D printer, you have a page, Control P, and you send it to the printer.
Yeah.
Or you're not playing around with the space between the dots and the size of the dots, and so I think I'm guessing that's what we're trying to achieve, right, for Helio?
Yeah, headless, right? Yeah.
And
then of course, with what's going on in generative AI. Kind of generating 3D models is getting super easy.
Yeah.
So of course, not from an engineering perspective yet, but from a kind of aesthetic perspective. So you could really imagine an end-to-end chain that's just from text prompt just to print, right?
Oh, to the model in real.
Yeah.
Like I wanna seated tiger.
Yeah.
And then that's your input, and the output is a part.
Yeah,
basically.
Exactly.
How long do you think that would take?
Look, I think from the physics modeling side, we're not far away from that. But I think the question is then integrating end to end.
Yeah.
Right. Somebody needs to get there and integrate that end to end. But things are moving so fast, right?
And faster and faster, right?
Faster and faster, which is pretty scary. So maybe 3 to 5 years.
3 to 5 years. Okay. Let me think. I would get, I think similar for me. What is this? We have 3 people in the family, and we each have several printers. 35 slides will go way too fast. Okay, so I think you said it was many different parts, right? That you had before. So
good feedback.
I
mean, we will calibrate this. What we found until now is that 35 number was kind of a sweet spot. It also balances our cost. You imagine that cloud compute costs are not trivial for us, right?
And I'm guessing you're continuously optimizing this, right?
For sure. But yeah, we can explore it in the future.
if we are to realize the automation of filament machine profiles, we will need more material data provided by filament manufacturers, things like melt index, co-poly blend percentage. Absolutely, and I think that's the you know where is Polymaker office? Where is it actually? Is there, right?
Yeah.
No, there.
It's there behind us.
It's just there. Which I couldn't show you around. It was a pretty busy business trip, but yeah, which is funny, right? I'm streaming from the Helio before I even show.
Yeah, I like that. That sounds good. But maybe on this, so we do all the material testing in-house. And so we'll get a material from Polymaker, for an example, right? And we have the standard operating procedures to test it. And then based on that data, build a really good kind of physics model, right? And to do that is really hard. I mean, that's our bread and butter. We have the standard operating procedures. Individually, none of those steps are really super complicated. But knowing what you need to do and how to get consistent data so that it performs is really not easy. Yeah.
And I think the two companies' engineers have been working a lot together.
Yeah.
Right?
And for sure, Polymaker has access to equipment that we don't have access to, right? So for instance, the rheometer over the TA rheometer over at Polymaker, my guys are using that constantly. We can't afford a rheometer.
So really a great partnership that also makes a lot of sense for what we're trying to achieve. Nero has that printer? Yeah, I don't remember the name of that printer. Printbot had an early attempt of online slicing. Okay, yeah, I remember some companies that were trying to do this.
Astroprint, right?
Astroprint
has got a cloud slicer.
Yes, that's true. Print in place, filament calibration. Is that something on your roadmap as an area to improve or remove as part of the printing process? Orca comes with lots of tools. Would be great to remove the human element error.
Yeah. So you mean things like print towers?
Oh, like stringing
towers
test, temperature towers, overhang test.
So effectively, with optimization, you do not have to worry about those things, right? You just click, and the optimizer will take care of it. So because we're already doing a large chunk of that.
When you build a profile, you basically do you spend the whole day printing, well, maybe not the whole day today, but hours on printing a bunch of models. So, I mean, that's why it's a core tool, right? You're able to simulate what is happening. So instead of waiting 6 hours for your print to finish, you wait 60 seconds to know what will happen.
Yeah.
What are your projections for when you take over the world?
As an evil person, I don't want to reveal that. So let me take over the world. No. Look, jokes aside, right? What we want is people to do amazing things with 3D printing. And we're this enabling technology that allows you to do more, companies to do more, and go to kind of the next horizon. And I hope, because we've got a team of amazing people, that whatever that next horizon is, we'll then have something that can push the envelope even further. Right?
Maybe a side question. What would be, like, from maybe a question for you guys also, is when you want to get a print, right? There is different, you need to play around with different things, right? Either you want it fast, you might sacrifice some others. Either you want it super strong, either you want it super high quality. And the idea is how you get the three of them, right? Super strong, super high quality, and super fast. Is there any other factor? Speed, quality, and strength.
Yeah, effectively.
Effectively, that's three, right? So ideally, either it's impossible, in which case the UI will have to ask the customer which one you want, and then we will optimize for that. But ideally, you are able to just do the three.
Yes, exactly.
And then you don't need a UI. Basically, it will always be optimized before going to the printer.
Yeah.
And you were talking about I don't know if I can talk about this or not, but the matte and not matte, is that something we can talk about?
I think we keep that.
Okay.
Yeah. I think it's important. Who commented before is some of the feedback has been negative and so on. We're doing something really complex, and results will vary. So I think it's really important that we only make claims that we're confident that we can achieve, right? That's why we put so much data on the wiki, because we don't want to claim stuff that we can't back up.
And Printbuster will help you with that.
Thank you. This is a really cool community. I'm loving the comments.
Flow calibration, for example, it depends on the nozzle, temperature, etc. I have a Bamboo default, B2 Revo, and a Mako hot end. So the nozzles are going to be different. That I'll have to calibrate the filament with those hot end nozzle.
Yeah. So definitely flow calibration. I mean, what happens in the extruder is one thing, and what happens in deposition is another, right? So in the extruder, you want to calibrate so that you're getting a steady extrusion out of your extruder. And of course, we do some flow calibration ourselves, et cetera, et cetera. But the key of what we're doing is in the deposition, right?
And I'm guessing the more you'll be able to integrate in the printing process, the better you'll be able to optimize, right? Let's say you have access to, all the extruder data, the flow data, pretty much all the setting of the slicer, et cetera, et cetera. So I think the more Helio can integrate in that ecosystem, the better it will be.
Yeah. And the G code, we take effectively what the API takes is the slice G code, and in there is already a ton of data, right? Enough data for us at the moment. But you could imagine a future where slicers use, let's say, more sophisticated formats than G code in order to bring more nuanced information. I'm excited by non-planar printing. I mean, we don't really have access to it as private people these days, right? Because there's no real consumer non-planar. But like those are non-planar, multi-material. Those are kind of things that are really going to push the envelope further. And that's exactly where we can shine, and where we can add value. Because that's the kind of stuff that's going to be super difficult to set manually.
Yes. Rando, would be so cool if Polymaker and Helio had an integration where if you bought Polymaker filament, you can use a QR code or RFID scan the filament automatically load with free Helio optimization.
Yeah, that's a good idea. I like
that's the sound of that. Idea.
Yeah.
Thank you, Rando, for the idea, which will most likely be implemented, I think. Very point. It would be nice to have you create profile for different hot end out there and have your algorithm determine optimal speeds based on ambient temperature, filament temperature, nozzle type, hot end type, and extruder type. Well, I think we are basically next to your lab, right?
Yeah.
Where you do all
so this is the kind of stuff that we're doing for at least for different materials and printer combinations. Yeah.
And that's so it's kind of you're doing the heavy lifting ahead of time in order for the optimization to basically work with anything.
Yeah, work as optimal with any geometry, right? With any part. Yeah.
So instead of everyone doing these tests in their home, it's being done once, and then you are able to use it because it's now part of the simulation.
Yeah, exactly.
What other data point would you want to see provided from 3D printers or users to improve simulation and optimization? Any sensor data?
So in the next version, so we've discussed in the next version of Bamboo Studio, we might have kind of a thumbs up, thumbs down button from people, because at the end of the day, it is useful to know, did this meet your expectation? Didn't this meet? I mean, it's good to do this in a live stream, right? Or see it on Discord, but it's better to associate it with a simulation ID. So we'll probably do some kind of feedback there. When it comes to sensor data, at the moment, we're fine with what we have with the G code. Knowing kind of what your ambient really was and so on, yes, that's useful. And maybe in the future, we'll do something like closed loop, right? Where everything is just happening live in the printer. But for the moment, we're fine with what we get back from the slicer.
And I think you did, so I remember a few years ago when I visited the office, you had some printer that had full of stuff on it, right? To try to understand. So once that's done, then you don't need to have all of this in.
Sure. I mean, our test printers will do a lot of thermal camera footage. We'll have thermocouples. we'll be gathering a whole lot of sensor data off the printer, right? We need to know, for instance, your actual extrusion temperature versus what your printer says, because these numbers are different, right? Your extruder is not giving you exactly that number, right? So we'll do all that testing, but then as long as your printer is reasonably maintained, we're good.
If you guys are onto something, I think you guys are onto something. Before, it was important to have individual people run calibration because everyone prints in different environment with different temperature. But if you're taking all that into account, then when optimizing, there is hope that will generate optimized code that works for anyone, anywhere.
And so to this, we also work with pellet 3D printing. I don't know whether you guys have ever used a pellet.
Maybe not.
No, because it doesn't really hit the consumer space. We have one customer, and they have like a fleet of pellet 3D printers. And what they were doing was they had to slice for every printer. So they were printing the same object on 10 printers, but they have to slice every printer specifically because every printer has a little bit variation, right? And what we're able to do with the optimizer with Helio is just hit the center of that process window so that one G-code, optimized G-code, will work on all of those printers, which I think bearded printers is kind of what you were talking about. One optimized code that then will work on any printer.
I think I have an answer for this question. Firms up down for whether simulation optimization are good, useful, might not be that useful because you don't necessarily know what's actually good, bad about it. Adding a text field for context would be helpful. Can be difficult to parse through AI. Yeah, I think for me, because that's what I said yesterday, right? I basically said exactly the same when we were talking about this. But one thing I understood is the following. The idea was not really to know whether the optimization worked or didn't work. It's the expectation from people. Let's take an example. I optimize and I end up with a 20% increase in printing speed. Is that good or not good? Right. So that's the idea. Like I'm happy that I earn 20% or not. That's like,
or in some cases, like we're showing this color graph, right?
Yeah.
When you have this color graph, it's, you might have a 20% change in strength, but you'll really struggle to see this as a changed color in the picture. So as a user, you might feel, oh wait, the optimizer did nothing, right? Because you can't see it because there's just so many voxels there and so many colors.
Yeah, so it's basically how, like we were just talking about, right? The core tech is ready. Now it's really about the product, understanding as much feedback as possible. Although a text would be really like exactly knowing. So I guess at some point is a balance between how much time people would put into giving feedback compared to, because not everyone is like, for example, you guys that are joining the live stream, asking questions, sharing your thoughts. People will even just a click thumb up, thumb down is would be great to have a conversion on that. Thank you, Devancy. But yes, so
this is a community with so many cool questions. I really like it.
Yeah.
I can't believe I never print busters.
That's
really cool.
So we started, I think what started it is really the understanding of, for example, warping, stringing, why parts are stringing, why they are warping, why do you get better overhang when you print faster or slower or higher temperature, lower temperature. And I think they, and I mean, it's a lot of very, very smart people.
From all around the world, or is it mainly US?
Yeah, where are you guys from? States, region, country, where are you guys from?
What's the time? I guess it's nighttime for Europe, so.
For Europe, maybe not much Europe. So we have US, what is Hollandica? Is that a country? US, Michigan, Texas, Oklahoma, California.
Anybody from New Zealand?
Oh, New Zealand. Oh, maybe. How about you? Are you willing to give a little bit of background where you come from?
Yeah. Do you think that would be interesting for this?
Of course.
Yeah. I'm born in Germany, so my parents are both German. But then when I was, like 2-3 years old, they immigrated to New Zealand. So I grew up as a New Zealander and kind of culturally New Zealander.
Yeah.
And then after university left and worked in a ton of different places. in the materials industry, working for Bayer and Covestro. So China, Hong Kong, India for 2 years, Germany, and then came back to China. So that's kind of my background and where I come from.
And we met, you were at Covestro, or it was Bayer?
It was Bayer at the time.
Bayer
it was
at that
before Bayer sold Covestro. Yeah, I was at Bayer. Oh, cool. Somebody was at Covestro. Hey, Little John Original. Where did you work at Covestro?
Oh, really? When I was
worked with Covestro. Okay,
with
cool.
Covestro,
Yeah,
okay.
yeah. It's a good company. In the US, they're in Pittsburgh.
From UK, Montreal, Taiwan.
Cool.
Same time zone as us.
Shout out to
Taiwan. NSGO, yeah, of course, NSGO. You know, I met, I was stuck in Taiwan because of COVID when I came back from a US business trip. And so I was stuck in Taiwan, right? I stayed like almost a month. And we actually met. And
That's awesome.
we eat together.
I wonder whether this community will also be at Formnext, do you think?
Will some of you be at Formnext? Noah will be at Formnext, that's for sure. But usually maybe from US people, usually Repra festivals is where they will go. There's some of them to Rapid, but maybe Formnext more for people that are around maybe Europe.
Little John Original. So PC was exactly the area that I worked in at Covestro and at Bayer. So that's why PC is my favorite material.
And most likely why it is mine. Come from David. And when you started Sending Aden, we had what's the grants for apps?
Yeah,
the accelerator, right?
Yeah, that was cool.
And I think it was only 5 startups out of like hundreds.
Yeah,
hundreds of startups, and we had to.
We were one of those 5. That was really awesome.
We pitched the idea. I remember we were all on the computer. Right?
Yeah, and you remember they didn't shut off, they didn't mute.
Yes. So yeah, that's how everything started. Good evening.
I'm still in touch with some of those people.
Yeah.
Yeah. So do you remember James from Vitamin?
Yeah, from Vitamin. Yeah.
So I was sitting in the Autodesk office in San Francisco on Pier 9, waiting for a meeting. It was maybe in 2017 or 18, and he just walks in.
Really?
Yeah, you think the world is so big.
Yeah.
And so since then we've kept in touch, and he visited me in China recently. It was really awesome.
Really nice. And it's just super glad to meet you in person, Nick. Yeah, and I still have the hope that you. So he gave me a couple of 3D printed tag that I put on my back, and it was like a happy hope, this type of thing. And I still have.
The hospitality in Taiwan is amazing.
Yes.
Anyway, yeah, just such a beautiful country.
Great. Any more questions for David? It's not often that we have access to the founder of the company. So if you have any questions, feel free to ask. And are you still sometime in China, sometime in Germany, sometime in New Zealand, or maybe?
Yeah, so I'm jumping around still quite a bit. Yeah, but definitely I'll be at Formnext.
Oh, okay.
In November.
So if any of you, oh yeah, of course, yeah. You're hiring the UX.
Yeah, so nice, Prints and Flags. Yeah, DM me and let's talk. Your ideas are awesome.
Do you know that a lot of recent hire at Polymaker is also from the community? Right?
That's really wonderful, isn't it?
Yeah, very passionate.
That's how it should work. Yeah.
I would like to G-code between layers, top, outline, things. What do you mean? Let me put that in big. I got one more idea. I would like to G-code between layers, top to outline thing. Sorry, I didn't get what you mean, Ram Online. That's mostly not possible. Yeah, so anything you would like to add?
No, look, guys, really super to interact with you guys. Nicola, thanks for this. Yeah, remember we are in beta, so if you see something that doesn't work for you, let us know. Be patient with us.
When will the Bambula A1 Mini be supported?
So P series and A series works in the lab right now. So we'll be releasing in stages because we don't want to stress the server too much, right? but we'll be releasing P series and A series within the next few weeks. Yeah.
Awesome. Well, it was really great to talk to you. Thank you for taking the time.
And you're just going to stay here and keep live streaming?
I will most likely continue to talk a little bit about the flowchart.
Yeah,
I'm really interested in the flowchart, but just a few more minutes. But yeah, thank you so much. I know it's a very stressful time, right?
Yeah, but it's been an amazing week, and thank you for everybody's support. Okay, awesome. Bye guys. See you.
Thank you, David.
See you, Nicola.
Okay, let me go back to the flow chart. I want to see, because there is some stuff that we talked together, and a lot of stuff surprised me actually in how things were, how they are solving things. So let me go back. And we need to brainstorm also all the testing that we need to do, right? Once I'm still in China now, but once I'm back in the US, we need to test. We need to do a lot of good testing. So let me check. Where was the flow chart? Okay, there you go. Because let me show you the one that I was the most surprised. I was late here. I'm gonna watch the VOD. Sounds like an interesting project. It is a very interesting project. Let me add this to the stage. Okay, so let me keep you guys for a few more minutes. I want to discuss a little bit what testing we can do, right? And you can let me know also what you want to test. So there you go. So dry material, calibrate max flow rate for material. So this is the prerequisite in order to make it work, right? Then you simulate. Okay, after the simulation is done, the thing that we are interested in here is temperature, okay? And so temperature meaning the not exactly the extrusion temperature, right? We're really talking about the overall, so like David was saying, thermal index, the overall thermal index. And this is the part that is really important to understand if we want to do the testing. So let's say it's too hot. What would be instinctively, no, maybe let's do the too cold. Instinctively, what would you do if it's too hot? The first thing I answered when David asked me was, I lowered the printing temperature. I mean, isn't that the first thing that come to your mind also, right? If it's too hot, then you just lower the printing temperature, right? And that's the first thing I was surprised, is that there is nothing related to printing temperature, which is something that we will want to test, right? So you have is the minimum speed reached? No. Then you reduce your fine speed, and so you see you're really not talking about the extrusion temperature, right? Because you see we're talking about the fan here. Increase speed, reduce layer time. Do you get my meaning here? Like, do you have that surprise? Like, would it be the first, like when we talk about increasing temperature and then increase your printing speed? Let me know what you guys think when you read that chart. Your temperature is too cold, so you need to increase your printing speed. And while you are typing some answers, I'm just going to blow my nose. And that's the thing I definitely want to test the impact of printing speed for different properties. Next one, if the max printing speed is reached, which is the reason why you need to calibrate the max flow rate, right? If the max speed is reached, then what else can you do that would make it hotter? So is cold part close to the build plate? If yes, you increase the build plate temperature. If no, you can increase the nozzle temperature So which is the first thing that we thought about at the very beginning, right? Or you increase the ambient temperature, so the chamber temperature, or you increase layer height, will reduce print time but have more visible print line. So increase layer height. So let me think about it. Why increasing layer height would make it hotter? Oh, I guess because it can maybe it can keep, because the the layer will be thicker, so maybe it can keep more heat. So I think that's the idea. And then suggest to keep constant throughout the print. If it's too hot, then if the max fan speed is not reached, then just increase the fan speed. When can you find this flowchart? You go on the Helio Additive wiki. So let me put that on our Discord here. So if you go on our Discord, discord.polymaker.com, there is a Helio Additive channel under our 3D printing partners, and I share all the link there. Okay, so if it's too hot, you increase your fan speed. But if the fan speed is already max, then you reduce your printing speed. So if it's too hot, you reduce your printing speed. And if the minimum speed is reached, then you reduce your build plate temperature, reduce nozzle. Okay, so it's the opposite of this one, and reduce layer height. Yeah, so we really need. So basically, my suggestion is when we do our test, we just go through this chart. Oh yeah, but we need to define a metrics that will tell us whether it has improved or whether it has decreased or whether it has gotten worse. And I believe the main thing is layer adhesion. So you know what we can do? We can print like a Z dog bone or multiple one. Yeah, let's see how we do this. Let me think. Yeah, a Z dog bone, and then we're gonna go through every branch of the chart, and for every branch of the chart, we record the Z tensile strengths, because we have the tensile tester now. So yeah, so I think that's what we're gonna do. We're gonna print a Z dog bone, and then we're gonna go through everything. So we're gonna have high printing speed, low printing speed, high nozzle temperature, low nozzle temperature, high fan speed, low fan speed, and all the different combination. And with this, we will have like a very nice matrix, and then we will follow the chart to see if it works. Do you think that's the best way? I think that's the best way. And then what we can do is we can do a game where we will go against the versus the optimizer, the Helio optimizer. So on one side, we will try to put our knowledge to the test, where we will try to optimize with our learning, optimize the best print, and see how we compete with the optimized print. You know what I mean? And then we can also use the microscope that we have for the surface quality, to see how smooth it is, and then the tensile tester for the layer adhesion, and potentially the impact strengths of the Z-axis. Basically, I want to use all the new toys that we received, but I think that will give us a very good idea. And then we can feedback this to the Helio Additive team. This sounds like an awesome software. Yeah, absolutely. Where can I find this flowchart? Already sent. Hard to pay attention. We just let our new kitten out of the room. We were keeping the mean. Actually, there's a cat here also in the office. Would it be helpful if there was an explanation for each suggestion in the flowchart? Yeah, I mean, the explanation for me is what I just said, right? Like, for example, reducing fan speed will basically keep your parts hotter. But anyway, I think the best is we do the testing, and then we observe the result. We make some hypothesis, and then we continue testing. And then we make some hypothesis, we observe, make some hypothesis, and then we continue the testing. Start with PLA. Yeah, we can start with PLA. I was thinking, you know what? I don't know. Because what we want is a material which will have drastic differences, right? Between the different, between the different setting. You know what I mean? Like, because maybe if you take PLA, you can change a bunch of stuff, but the result is very similar. But if you take something like ABS, ASA, or PC, any of the high TG amorphous material, then maybe these will show you the biggest result, or the biggest result differences. You know what I mean? Like if you, with fan or without fan, might have very big differences. High temperature, low temperature nozzle, high printing speed, low printing speed, you might have like some really big result where you will really quickly understand how it affects the print, at least for PC. And then we do the same for ASA and ABS. And maybe we can extrapolate that amorphous material works more or less this way. And then PLA, which I think in 3D printing can be considered as an amorphous material, then we try the same. But for nylon, it will be difficult, right? Because nylon is able to crystallize during the printing. So that would be a completely different story. I mean, the explanation from Helio Additive, and then we can compare notes from our testing. Yeah, that's a good point. Yeah, maybe we can ask them how it's supposed to react and why, and then we just do the testing. What temperature will you start with? Polymaker recommend middle temperature. Yeah, I'm not sure. I mean, we can do like for PC, let's say we start at maybe 240, 250, 260, 270, 280, and then we see how it goes. PLA too forgiving. Yeah, that's what I'm afraid. I'm afraid that if you do all the tests with PLA, there is barely any differences, and then it's hard to draw some conclusion. So higher TG, I think that's where the Helio Additive will shine better, is the material that are harder to print, basically. But anyway, I think that's what we can plan to do once I go back. So I will go back to the US on Wednesday. So potentially Friday evening, if I'm not too tired, we can start some testing. Yeah, what do you think? Any other ideas of what we should test? Printing speed, print time, maybe overall print time. But yeah, you guys can play around with it. Again, the simulations are free, and then if you contact David, you can get optimization for free. So you can play around with it, and then you can draw some conclusion or some hypothesis. Sorry, you draw some, you have some observations, some hypothesis, and on the Discord, you guys can send some ideas of tests that we can do. Yeah, what do you guys think? All good? Will you be at 3D Printopia next week? No, unfortunately, no. That's the first Reprap Festival that I'm going to miss, but I will come back pretty late. So I'm leaving on Wednesday, so I will arrive on Thursday, I think. So I won't be able to make it for 3D Printopia. Okay, I think that's it. If you have some other ideas, just let me know. So thanks again to all of you. Print and Planks, thank you for all your great questions. JLo, Ramolin, thank you. Rendo Tech Nerds. Paisley's, thank you for sticking around. Non-fam, what a wonderful fun stream. Maybe you could try a Helio optimized print with lower infill to see if the optimization makes us strong with less material. Yeah, that's a good idea. That's a really good idea. Like the lightest, strongest material. Okay. Thank you, everyone. Have a good rest of your evening, I guess, because I saw most of you were in the US. And we'll try to have a stream on Friday. So don't miss the Friday stream. And don't forget to reach out to David to get some optimization. Thank you, guys. Have a good one. Bye-bye.